All right, looks like we are live. If you can hear me in the chat, let me know. Put a plus in the chat if you can hear me. That would be great. I would greatly appreciate that just so I know that I'm not talking to myself. Hello, AQA. What should I call you? Neil? Hi, Neil. Thanks for letting me know you can hear me. Love that. Thank you for waiting so patiently in the stream. I saw a couple of you waiting. Thank you for being early. Hi, Zong. Welcome back. I see you returning. Love to see that. Well, today is my very last free live stream. Thankfully, it is on Algebra 1, our free live stream. Hi, Avery. Welcome back. We have forming and solving equations. Yeah, looks like a lot of us are back, returning. If you're new, feel free to say hi. You might have to subscribe to the channel in order to chat today, so feel free to do that as well if you want to participate. I'm good. I'm good. Thank you for asking. I hope you are well as well. I know it's 5 p.m. in the West Coast right now, but 8 p.m. in the East Coast. If you're tuning in from the East Coast, kudos to you. You're here to learn. You're here to build confidence in your math class. Love to have you here. Happy to have you here. All right, before we begin, if you could do me a favor, copy that URL at the top of your browser, share it with a friend, a family member, just be supportive. Whoever in your community you think would benefit from today's lesson, bring them on over and we can have fun together. 1 a.m. here in the UK. Wow, that's amazing. Why are you still up? You should be asleep, no? Already sub and turn on notification. Amazing, Avery. Love to hear that. Let me introduce myself really shortly. I'm Eddie. I'm the senior math teacher at my EdSpace. I've been teaching for about 9 years in high schools and colleges, private tutored every grade level from 6th grade math all the way to students preparing for graduate school. After graduating from UCLA, I started teaching right away. I found I was super passionate about it. And it showed because my students got into the top universities. Yeah, I mean, they got 800s on the SAT math section, 5s on the AP exams, just really did really well in math. But most importantly, they had fun doing it. That's what I'm here to show you. I'm here to show you that math can be fun, that you can be confident in your math class, and that you can hang with the top dogs at your school and maybe one day even be that top dog. So here we go. APKs. I love starting with APKs, accessing prior knowledge to all of my lessons. So in the chat, what is the sum of the 3 interior angles of a triangle in degrees? Let me know in the chat. What is the sum of the 3 interior angles of a triangle in degrees? Zong, 180. Inaya, 180. Awesome. Hopefully I'm pronouncing your name correctly, Inaya. Let me know if I'm not. But great, that was super quick. What is the sum of 3 interior angles of a triangle in degrees? You are correct. It is 180 degrees. This is knowledge we'll have to know to access some future questions in today's lesson. Great, Avery, as well. What is the area of a trapezoid? Knowing that one side is A, the other side is B, the height is H. Awesome, Inaya. Great. 1/2 A plus B times H. Zong, amazing. We already know Zong has been here. So the way that we did it last time is we said, let's double this trapezoid, flip it, and attach it. Now we could do base times height. But this length right here is B. So if I do base times height, that's A plus B for the entire length times our height H. But remember, we duplicated this trapezoid. So we want to divide by 2. And that's where Zong got the area of a trapezoid for us. Same with Inaya. Awesome. Base sub 1 plus base sub 2. I see you know how to use that in our live chat as well. Amazing stuff. Let's keep moving forward then. Nice. Find the value of x given the following angles. I don't understand triangles 180. Zong, all good. Thank you for asking. This is how it works. Let's say we have another line up here. Then let's say this line is parallel to this line. By alternate interior angles, this angle has to be the same as this angle. and this angle right here has to be the same as this angle. So a line we know creates a 180-degree angle. So if we add all three of these angles, that has to equal 180. That's why the three interior angles of a triangle add up to 180. Did you get that, Zhang? That's the way we prove it. Yeah, zigzag. Exactly, zigzag. So find the value of x given the following angles. We have these three interior angles. We know when we add them up, it's going to equal 180 degrees. So we go 2x plus x plus x. That's 4x. Then we go 10 plus 30 plus 20. That's 60. And that is going to equal 180 degrees. And all this is in degrees, right? So we have 4x degrees is equal to 60. Going to be subtracting here. And now x will equal 30 degrees. Just like that. Amazing. Okay, let's take a look at this one. The area of a trapezoid. Great work, by the way, Inaya, Zong, and Avery, catching up and staying with the class really well. For those of you that haven't participated or had a chance to participate yet, don't worry. You can participate right here. The area of a trapezoid is 10 units larger than the area of a parallelogram. Okay, so let's put this down as an equation. The area of a trapezoid is 10 units larger than the area of a parallelogram. The area of a parallelogram, just like that. So what we get here is the area of a trapezoid, yes, Zong, is 1/2 a plus b times h. The area of a parallelogram will just be base times height. So the area of the parallelogram here is just going to be 8 times x plus 5, and that gives us 8x plus 40. Ooh, Inaya got 4 already? Let's take a look. Maybe. Actually, I think you're correct. So the next one, the area of a trapezoid will equal base 1, 5x plus 2, plus base 2, and this is a plus b, times the h, which is 4. Don't get confused. It's not the 5x, all over 2. Notice how 2 and 4 have a common factor of 2, so we can simplify before we distribute. Let's combine all like terms within the parentheses first. So we get 9x plus 5 times 2. That gives us 18x plus 10. With this information, we can plug it all straight back into this equation we created at the very beginning. So now we have 18x plus 10 is equal to 10 plus 8x plus 40. And let me know what you get for x in the chat. After this lesson, we'll be doing more that you have to join a course for. What do you mean, Inaya? Do you mean if I have another lesson after this? I see Inaya got 4. Anyone else find x yet? We can combine like terms. 18x minus 8x gives us 10x. And then we can add, well, we know we have 10s on both sides, so these will eliminate, leaving just a 40. And it looks like Inaya did get it correct. So did you, Avery. 4 is correct. And we have found the value. Like in the UK. Araceli, is that how you pronounce your name? Welcome. Yes, 4 is correct. Zong, let me know. I don't understand. Be a little more specific. Which part did you not get? Yes, my courses in the US will be starting on Monday, Inaya. Just so you know, to answer your question there. The whole thing, Zong, I don't know if I can repeat the whole thing, but that's okay. The next problem we do, it's another re-entry point. So also, excuse me. Also, all my lessons are recorded. So you can always go back and check to see what you may have missed later on after the lesson is over. So hopefully that works for you. Let's move on to the next one for now and see how that goes. Maybe I'll go a little slower here. Of course, yes, you can rewatch anytime. Exactly, as Inaya said, nice. Emilia is 15 centimeters taller than Sophia. Let's say E for Emilia, S for Sophia, and J for James. So, if Amelia is 15 centimeters taller than Sophia, how would you write that as an equation? Everyone in the chat, how would you write that as an equation? Amelia is 15 centimeters taller than Sophia. Okay, 15 plus S, Zong, giving us a good start here. 15 plus S. Araceli, adding on, E is equal to 15 plus S. Love that. Yes, Amelia, E, is 15 centimeters taller than Sophia. So E equals 15 plus S is beautiful. Yes, exactly, because is taller. Amazing work. The next one looks like Avery's ahead of the game here. James, J, is double the height of Sophia. So double the height means 2 times. So as Avery just told us in the chat, J is equal to 2S. Great. Now, their combined height is 3.35 meters. How would I write that as an equation? Their combined height is 3.35 meters. Is Sophia 80 centimeters? Not sure yet. We're not there yet, Inaya, but maybe it is. So their combined height, we have Amelia. Okay, I see Zong has some idea here. Avery as well. Amelia plus Sophia's height plus James's height all together equal 3.35 meters. Okay. Do we have to make sure of anything before we move on here? Let me know in the chat. Is there anything that we might have to change before we continue on in this problem? Is there anything we want to fix in this problem before we move on? What do you think? Not sure. Okay, let's keep moving forward then. We want to find Sophia's height. So Sophia means S, right? So S we want to keep the same. And J is already equal to 2S. So for J, we could substitute 2S. I'm going to pause there. What I did here, if I were to color code, is 2S is equal to J. So J will be equal to 2S. That's what we just did. And I see Avery is ahead of the game here. We know that E is equal to 15 plus S. But S, what is S equal to? We can change this to say S is equal to 1/2 of J. So I can plug in S into, or 1/2 J as this S. So don't forget to do that. Or actually, we don't even have to do that, do we? I'm going to cross this out. We already have E in terms of S. Let's just use 15 plus S. It is simultaneous equations. Yes, in the UK, you do call it simultaneous equations. In the US, we call it systems of equations. But 3.35 meters. Is that the correct thing to write here? 3.35 meters. Because right now, this 15 is in terms of centimeters. So we need everything to be the same units of measure. So instead of 3.35 meters, we know that 1 meter is 100 centimeters. Yes, Zong, exactly. We must convert. So we have 335 here. And that's part of the reason I put meters here, just to give you a little hint. But it seems like no one noticed until now. All good. But let's check. Let's add all the S's up. That's 4S. And now we have subtract 15 on both sides. We have 320. S equals 80 centimeters. And it looks like, Inaya, you were correct from the start. 80 centimeters. Looks like you've watched my previous lesson before. So you have quite the head start on everyone else. Hi, River. Welcome. Yes, of course. Glad you're enjoying it. It's going to keep going. So stick along. All right. Looks like Zong, you got this one as well. Let's try this next one. Try this one on your own. Start it out. I'm going to start doing it very slowly, but see if you can start this question on your own. And after a while, see if you're on the right track as you're going through it. Okay? So for me, I'm going to say A for Alice is 5 years older than Julian. Okay, great. Now, the next line says Nate is 3 times as old as Julian. So it's not 3 plus J anymore. It's 3J. Their combined age is 75. Exactly, Zong. Their combined age, A plus J plus N, is equal to 75. So in my previous lesson doing this, what I did, in order to solve for Nate's age, I put everything in terms of N. But I recognize right now that I can put everything into terms of J pretty easily. Right? Do you notice that? I could put everything in terms of J. So if I can find J and then multiply that by 3, I get Nate's age. So I'll say 5 plus J plus 3J is equal to 75. So this is a new way of doing it from our previous way of doing it last week. So we have 5 plus 5J is equal to 75. So 5J is equal to 70 and J is equal to 14. So Nate is equal to 3 times Julian's age. So Nate is equal to 3 times 14, which is equal to 42 years old. So Nate is 42 years old. And a fun fact about the number 42, 42 is the angle at which a rainbow starts. Did you know that? If you didn't know that, put a W in the chat because you just learned something new today. All right, let's try the next problem here. Oh, Zong, you don't understand. Which part? Mind blown, yes. Sub in for which one? We're looking for Nate's age. We put a 14 in for the J. We substituted. First party. This part right here. Yes. Okay, great. So if I were to color code this, A is equal to 5 plus J. Now the J plus J just came straight down. And in green, N is equal to 3J. So if I color code this, does that make a little more sense? It's basically just filling in a puzzle almost, right? Hopefully that helped. And we're going to have at least 4 more problems here. So let's take a look. The length of a rectangular field is 4 times its width. So let's do, yes, substitute in exactly, Zhang. Here is a rectangular field. Is 4 times its width. The length is 4 times its width. So here's the width and here's the length. They're telling us the length is 4 times its width. 4 times the width, just like that. Great song. 4W, exactly. The total perimeter of the field is 60 meters. Perimeter. Perimeter means the length around something, one time. So if we add up everything here, we have 4W, we have W, we have another 4W, and we have another W. So essentially what we have here is 2 times the 4W and 2 times just the W. And what does it tell us the perimeter is? 60 meters. 60 meters. Okay, let's solve. 2 times 4W is 8W plus 2W. And we solve 10W equals 60, so W is equal to 6. Now, great, Avery. What are we looking for here? What are we looking for? What is the question asking for? Let me know in the chat. We are looking for the area of the field, right? The area of the field. Great, Adeseli and Zong. We're looking for the area. The area is length times width. The length is 4w. So here's 4w. And the width is w. That's 4w squared. W is 6. So it's 4 times 6 squared. So 6 squared is 36 times the 4 gives us 144. But if you just write 144, I personally would mark it as not fully correct. What are we missing? We've been talking about this in our free lessons. What are we missing? Whenever we are given units of measure in the problem, we must include it in our final response. Exactly, the units. Area is two-dimensional, so our units of measure must be squared. So Inaya, you were spamming 144 earlier, and I saw it, but I didn't respond because you were missing the meter squared. I didn't want to tell you were correct, because then I would have been lying to you. We have to put units because the problem gives us units. Whenever a problem provides units for us, our final answer must also have those respective units. If a problem doesn't give us units of measure, then our final answer does not have to have units of measure as well. So hopefully you learned something new today. Okay, Naya, whatever you say, I'll believe you. All right, let's try this next one. If it was centimeters, yes, it would be centimeters squared. That's correct, Avery. Exactly. Amazing. Yes, great clarifying question. In this problem, we have in 5 years, I will be twice as old as I was 15 years ago. I see you, Inaya. You're learning. We love that. And that goes to show when you make a mistake and you fix your mistake, that's when you truly learn. That's when retention occurs, right? If you don't make any mistakes, that means you're not trying. So you're not fixing anything. Therefore, you're not really learning anything, right? So don't be afraid to make mistakes because when you fix your mistakes, that's when true learning occurs. All right. In 5 years, I will be twice as old as I was 15 years ago. These are like some of those brain teasers that make you think too much. And that's why without thinking too much, let's start writing first. In 5 years. Right now, I don't know how old I am right now. So let's call that X. In 5 years, in terms of X, how old will I be? Let me know in the chat. In 5 years, if I'm X years old right now, in 5 years, how old will I be? Okay, Zong says 5x. 5x would mean 5 times x. So let's say I were 10 years old right now. 5 years from now, would I be 50 years old? Because I'm multiplying by 5? (10 minus 5). So in 5 years means 5 years later, right? So Avery said 2x minus 15. Pretty close, but we would be x, thank you, Anaya, plus 5. Right? If I were 10 years old right now, in 5 years, will be plus 5. If I were 20 years old right now, in 5 years, I'd be 25. So it makes sense that we do the plus 5. Now, in 5 years, I will be. So that's another way of saying equal to. Twice as old as means 2 times. I was 15 years ago. What is my age 15 years ago if I'm still X years old right now? What is my age 15 years ago if I'm still X years old right now? Zong said X minus 15. Does everyone agree? Yes, Araceli, awesome. X minus 15. And I need parentheses around this because 2 times. Twice as old as I was 15 years ago. It's not twice as old as I am right now and then go back 15 years, right? So this says 2 times X minus 15, just like that. Okay, now we have something to solve. Again, how old am I now is our x, so we can solve for x. Let's distribute. We have x plus 5 is equal to, let's distribute this 2. So I have 2x minus 30, and now solve for x. How old am I right now? Let me know in the chat. "35 years old." Thank you, Naya. Do I look 35 years old? If you solve this out, you do subtract x from both sides. And again, one thing I like to do is I like to keep my coefficients of variables positive. So notice how 2x is greater than x here. I'm going to leave the x on the right side. So I'm going to subtract x on both sides to leave that positive x on the right. I add 30, or I move this negative 30 to the other side of the equality, becomes a positive 30, and I get 35. Get comfortable with having the variable on either side of the equality. Okay? I'm going to practice that because whenever we work with 3 types of numbers, negative numbers, really big numbers, and fractions. These are the 3 moments or 3 types of numbers that cause the most number of careless mistakes. Negative numbers, fraction numbers, and really big numbers. So that's why I try to shy away from negative numbers, especially when we're trying to isolate for a variable. I look 25? Wow, I'll take that as a compliment. Yes, so how old am I? I am 35 years old. And that would be the end of our problem. Can you believe already half an hour has passed? Let's do a couple more problems here. Let's take a look at this one. Forming equations practice. Try to create an equation yourself based on what we just did in our previous slide. Once you have an equation, put it in the chat. And I'll give you a minute or 2 for this. And then let me know. Avery said, no moderator here? Time to go crazy. 24, 25, wow. In 7 years, I will be 4 times as old as I was 8 years ago. How old am I now? Looks like Araceli is like, this is light work now. I know exactly what we did in the previous slide. I'm going to use that knowledge and create an equation for this problem so quickly. I like the question mark as well because, you know, we're not sure, but at least we're trying, and that's what I like to see, right? At least we're trying, at least we're putting in our effort, our best foot forward, and that's what we like to see. Let's check this out. So it looks like all of us got the same thing on the left side of the equality here. In 7 years means how old am I now? X plus 7 years in the future. Now, I will be 4 times as old as I was 8 years ago. So 8 years ago, I was X minus 8 years old, but I'll be 4 times as old as that. So make sure you have that X minus 8 in parentheses. If you do not have it in parentheses, you're going to make a mistake, right? 4x minus 8 will not get you that same answer. So now I have X plus 7, and we have 4x minus 32. And now I want to solve for x. I want to isolate x. So I'm going to subtract x from both sides to get 3x on the right. And I add the 32 to both sides to get 39. X is going to equal, what do we get? Everyone in the chat, what is x equal to here? 39 divided by 3, we have 13, right? So I am 13 years old. Wow, 13 years old feels like an eternity ago, but some of you, you are probably 13, right? Or 14 maybe. And that's why I created this problem for you right here. You can give this problem to your parents or to your family friends. Say, you know, in 7 years, I'll be 4. Next time they say, how old are you now? Say, well, in 7 years, I'll be 4 times as old as I was 8 years ago. And then that'll be really fun. All right. Here is our very last question for today. Let's take a look. The sum of two numbers, x and y, is 45. How would you write that as an equation in the chat? The sum of two numbers, x and y, is 45. How would you write that as an equation? Okay, Araceli, great start. X plus y is the sum of x and y. And Avery, great, helping out, is equal to 45. Is teamwork makes the dream work. Love that. Zong as well. X plus y is equal to 45. Love that. Now, the difference between them is 15. But now I can do x minus y equals 15 or y minus x is equal to 15, right? We don't know yet. But what tells us which one to use? Very great. You've been here before, that's all you know. But we are given that x is greater than y. Since x is the bigger number, it makes sense that the bigger number minus the smaller number equals the positive 15. That's how we know we use this one and not the second one. I'm going to pause here so you can register that, right? So now we have x plus y is equal to 45 and x minus y is equal to 15. A couple ways to do this. The way that I like to do, the easiest way to solve, this is what we call a system of equations. In the UK, as some of you are here for that, it's called simultaneous equations. But the easiest way to go about these is to add straight down. Because what we notice here is that when we add y and negative y, these go poof in the night, they eliminate. And when we add x and x, we get 2x. And so what do we get x equal to? Let me know in the chat. 45 plus 15 is 60. What is x equal to here? Inaya already had it queued up. Love to see it. Zong, thank you for joining in today. X will be equal to 30. If x is equal to 30, what is y going to equal? In the chat. If x is equal to 30, y has to be equal to. We'll give some other students a chance, Inaya. I know you have it already. Yes, Zong, that's exactly what we can do. We can plug in 30 back into either one of these equations, and they should give us the same thing. No need to be sorry. All good. We love it. Araceli, great as well. 15 is correct. Zong, thank you for showing us the steps to do it. We want to plug it in into one of these. So maybe 30 minus y is equal to 15, and we know y has to be 15 in order for this statement to hold true. We could have also done 30 plus y is equal to 45 using our very first equation, and we subtract 30 from both sides to get y is equal to 15. And we could check our work. Do the sum of these two numbers equal 45? Yes. Does the difference of these two numbers equal 15? Yes. 30 minus 15 is 15. Is x greater than y? Yes, 30 is greater than 15. After you complete a problem, always check to make sure that your answers make sense, right? Always check to make sure your answers make sense, because if you don't, you may have done everything correct except for maybe one little careless error, and that's going to ruin the entire problem. All right, if you're still here with me, then put a plus in the chat. Let me know you're still here. If you enjoyed today's lesson, call your parents over right now because our free lesson is over, but your progress doesn't have to. At my Space, my Algebra 1 full year course starts on Monday. So soon. Each course includes 2 of these types of lessons every week. So each week you get 2 lessons. That's 8 lessons per month. Every lesson is recorded. As I said, this lesson is also being recorded so that, let's say your teacher is doing this 3-4 months in the future, you can always come back and review this recording. Every lesson comes with professionally designed workbooks that help you to not have to copy down every problem, and you can focus on the learning. After every lesson, you'll get a problem set of 5 practice questions, exam-style questions to make sure you've mastered these concepts and skills. And I don't leave you hanging. I create these detailed video solutions so that you're able to check your work and maybe learn new ways of doing things, because in the video solutions, I give you little tips and tricks as well. But how much is it? For context, when I used to be a private tutor, how much do you think I used to charge? And let me give you a little story about that. In high school, I used to tutor and volunteer pro bono, meaning for the public good. So I did it for free. But all I really could do was the lower levels of math and just homework help. In college, I used to charge about $30 to $40 an hour because now I'm at UCLA. I'm a math major. I know what I'm doing. I can help with all levels of high school math as well. But still, just homework help. But now, 7, 8, 9 years into teaching and in a classroom, in college lecture halls, on online settings, I used to charge minimum $100 to $200 an hour. And that's what families have to choose between, what works and what they can afford. Families, parents, you have to choose between what's affordable and what's effective, but not anymore, because that's why we created MyEdSpace. You get both affordability and effectiveness, all for $99 a month, which is 8 times cheaper than what I was charging per hour as a private tutor. So basically, $99 a month, you could have paid for 1 hour with me. Why stop there? We have a 20% additional discount on our annual package if you are able to purchase the entire year course. 20% off, and I believe each lesson comes out to less than $11 per lesson, which is pretty insane. And to protect you from any risks, we provide a 30-day risk-free full refund guarantee. This is just because I'm confident that once you start with me, you're going to love it. You're going to be more than satisfied. First come, first served basis. This is a limited time offer. So if you're interested, text me code word START to this number. You can scan the QR code and we can get your journey at MyEdSpace started with me. If you have any questions, I will be here to answer any questions you have for maybe a minute or two. But other than that, thank you for your time this evening. I hope to speak to you soon. Remember, my course starts on Monday. So in order to get you registered properly, sign up as soon as you can. Zong, Inaya, Avery, Araceli, Raymond, thank you for joining in today. Really appreciated you guys for your participation. And anyone else that was here as well. Inaya said, this was my first American math lesson. Amazing. Avery, yes, today was a quick lesson. 120 USD, that's a good guess. £5 an hour in the UK, yes. See you in the main course, Avery. See you in the main course. Excited. So excited. All right. If there aren't any more questions, have a great evening. These free live lessons were so fun for me, and I hope they were just as fun for you. I'll see you all in the main course starting on Monday.